Okay, those of you that are new, I'm going to go pretty quickly through this stuff because those that had pre-algebra learned this pretty well. So you may need to be careful and you may need to do some additional work here because, again, I know what I taught the pre-algebra class last year and I know they know this stuff well. All right, so properties of numbers. First off is the commutative property. C-O-M-M-U-T-A-T-I-V-E. C-O-M-M-U-T-A-T-I-V-E. The commutative property. Basically says this, and we're dealing with addition right now, we'll deal with multiplication later. When adding, what can change, class? Commutative. You can change the order. And that's the key to commutative. And that's what you have to associate with commutative, order. The order can change. So, in the example there, we have the A is first and the B is second. So on the right-hand side, we can switch the order. We can put the B first, and we can put the A second, right? We can change the order. A plus B now equals B plus A. That's the commutative property. And it's telling you in the course of doing your math, if you want to, you can change the order. Comes in very handy at times when you're adding. You don't need to write this, but, let's suppose you were adding a string of numbers up. And let's suppose you had a 9 plus a 3 plus a 7 plus a 1. Hey, if I add the 9 and the 1 right now, I got 10, and then this is 10, the answer is 20. Or I can change the order that I'm adding because it's to my advantage, right, daydreamers? So it's to my advantage, and daydreamers are still daydreaming. All right, very interesting. So when you daydream, by the way, you're not really listening, and that's not good in math class. So, commutative property, you can change the order. You can change the order. Don't let the letters throw you into a tizzy. Oh no, it's letters. All the A means is the first thing. The B represents the second thing. Now we switched it, put the second thing first and the first thing second. So here with variables 3y plus 5z, go ahead and finish the commutative property. What would you do to finish the commutative property? And hopefully you switch the order, right? No big deal. Commutative, you can switch the order. Order in the court. Okay. That brings us to the next one. And that's the associative property, A-S-S-O-C-I-A-T-I-V-E. A-S-S-O-C-I-A-T-I-V-E. By the way, see, some of you new people don't have 4-color pens, and I'm just telling you, it's to your advantage to have a 4-color pen, and things are color-coded on purpose, and color is used on purpose. I am trying to associate red with commutative with your brain, and whenever I use the commutative, I'm going to use red. Later on when we talk about commutative multiplication, it'll be in red. I'm trying to associate some things with your brain. Associative's always in green, identity in blue. I'm trying to make these connections in your brain. Those of you that are in black and white, you got no connection. It's all black and white. You don't have that connection. Also, when we're doing math, we'll do steps. We'll use color in our steps. Why? Not only for the association, the addition step will always do in red, the multiplication step will always do in green. Why? Again, to make those connections in your brain. But beyond that, all of you had this happen. In math class, everything made sense. You get home, you look at your notes, you don't know what's going on anymore. Because you got a bunch of black and white stuff, that's why. Where our color illustrates and highlights the steps so your brain remembers them and can identify them again more easily. That's why we use 4-color. So I think every new person in here, except for one, except for 2, is not using 4 colors. So you need to get the color. Okay, enough philosophizing. Class, the associative property says you can change the grouping. So when you think associative, you want to think grouping. parentheses does grouping, and on the left-hand side, the B is grouped with the C. Now, we're not changing the order, so it's still going to be A plus B plus C, right? The order's not going to change. That's commutative. But the grouping is. So now we're going to put the parentheses between the A and the B. All right? So on the left-hand side, B and C were bestest friends. And on the right-hand side, out with C and in with A and B are bestest friends. Must be girls. Because if it were guys, let me show you what would happen if it were guys. If guy B and C were friends, and then guy A came along, that would be, and it wouldn't be, so that would be how guys would do. Okay, good, cool, one more. 3 of us. All right, 4 of us, 8 of us, 10 of us. Girls got to be 2. I don't know why, but anyhow. All right, so commutative, that was free. I just threw that in for you. All right, so anyhow, associative, grouping, and so B is grouped with C on the left, A is grouped with B on the right. The grouping changed. That's associative. So with numbers, again, the order stays the same. You change the grouping. And just to show you that it works, if you know the order of operations, we're supposed to do stuff in parentheses first. So the left is 3 plus 9, brother. And the right is 7 plus 5, right? And sure enough, 12 equals 12, and sure enough, the property works. We're able to change the grouping and not change the value, and that's the idea. So grouping is associative. Come on, go away. Shade, what is your problem? I can't get rid of it. There it is. Brother. Technology, love it or leave it. Okay, next one is the identity property. Identity. I-D-E-N-T-I-T-Y. Identity. All you DeLorean fans like this one because it's back to the original. Back to the original. What did that have to do with the DeLorean? Back to the future, yes. All right. So back to the original. So keep my blue. You notice you got a blue A on the left. You add 0 to it, and what do you end up with? A blue A. You're back to the original. Add 0 to anything, you're back to the original. That's the identity property of addition. And 0 is called the identity element of addition. Meaning add 0 to anything, you're back to the original. Add 0 to anything, you're back to the original. So of course 3 plus 0 equals 3. So 3x plus 0 has got to equal 3x. And negative 8.13y squared plus 0 has got to equal negative 8.13y squared, right? Because 0 plus anything is back to the original. Piece of cake. Piece of cake. I'd rather have pie, actually. Apple with vanilla ice cream. There you go. I'm going to do pie. Let's do apple. All right, the last one in black, at least of these 4, is the inverse property. The inverse property. And there's no quick little key thing on these, except the concept of add inverses, or I'm sorry, add opposites. You could also say inverse, but opposites is better. Add opposites. So what's the opposite of A? Negative A. And whenever you add opposites, the sum is always 0, right? So we add opposites, we end up with 0. So that's the inverse property of addition. You add opposites. So 3 plus negative 3 is 0. (3x plus negative 3x is 0. And do I have room for this one? Negative 8.13y squared plus 8.13y squared equals 0, right? Opposite numbers. Who cares if there's a bunch of variables? One's positive, the other's negative, same thing. This is a negative 8.13y squared, and a positive 8.13y squared is going to give you 0, right? One's positive, one negative, everything else the same, 0. Right? 0. 0. Good enough? Good to go? All right, I'm going to keep rolling. Going to keep rolling along. Okay, so again, those of you that are new, you got to be careful here, because last year I spent a lot of time in getting everybody to be really good at adding positive and negative numbers. And we took it step by step, day by day. And we would have taken like 4 or 5 days just to make sure we're really good at adding positive and negative numbers. And all of you that were in pre-algebra last year, you are really good at adding positive and negative numbers. So we're going to do all of those 4 or 5 days right now in the next 20 minutes, maybe 15, maybe 10. Because you already know, right? It's old hat and you're good at it. All right, so let me refresh your memory. Remember, think of the number as that amount of positives or that amount of negatives. So a negative 3 and a negative 2 is 3 negatives and 2 more negatives. Just like 3 apples and 2 more apples. It's 3 apples, 2 more apples, that's 5 apples. 3 negatives and 2 more negatives is 5 negatives. Answer, negative 5, right? Piece of cake, no sweat. We can do that. Well, then you got to be careful in this scenario, and this wants to throw off students. But remember, what did I just teach you? Keep the sign with the number. This is 7 negatives and 4 more negatives. So take a minute, take your black, and write negative 7. I'm going to use a blue plus sign plus parentheses negative 4. That's the exact same thing. Negative 7 minus 4 is exactly the same as negative 7 plus negative 4. In math, we always do the shorthand. We always write as little as possible. Why? So we can confuse students. That's why. No, because we just always do the shortcut. But it can confuse students, right? I mean, this is clear. 7 negatives and 4 more negatives. For some reason, this is what some students falsely think. Negative 7 subtract 4. That's not a good thought. You don't want to think that. Don't think negative 7 subtract 4. Your brain will have a hard time wrapping it around that. When you look at this, you should think 7 negatives and 4 more negatives. Okay, that's easy. 7 negatives and 4 more negatives. Oh, how about 11 negatives, right? This is 11 negatives, which we know is negative 11, right? So when you see it, negative 7 minus 4, you got to make sure you're thinking 7 negatives and 4 more negatives. If you do that, you're in great shape. It's easy. Piece of cake. Wait, piece of pie. Apple pie. Ice cream on top. Okay. So henceforth and to with that in mind, C has to be negative 17. Piece of cake, right? We're done. Rolling on. Next question. Because it's 3 negatives and 14 more negatives. And D has to be negative 18. Onward, forward. Shout aloud, Hosanna. All right, on we go. If you'll think of it as that amount of negatives. It's easy. At least it's supposed to be. Okay. So what happens when we start adding numbers with different signs? Don't let the word addend drive you crazy. Come on, stupid thing. Don't let the word addend drive you crazy. It just means adding 2 things. So what happens when you add 2 numbers with different signs? In other words, what happens when you add 1 positive number and 1 negative? All right. always be sure that the sign of the sum, the sign when you add them, is always the sign of the addend, the one with the one with the most. Because you're always going to have positives, you're going to have negatives. Newsflash. If there are more positives than negatives, your answer will be positive. If there are more negatives than positives, your answer will be negative. It's always the sign of the one with the most. So, you new people, I don't know if this is what you learned in your school. I always think of the scarecrow in The Wizard of Oz when I say this. Because here's the book definition of how to add one positive and one negative. Take the absolute value of the one with the most, subtract from it the absolute value of the one with the least, give the sign of the one with the most. All right. You may have learned that. It stinks because you have no earthly idea what you're doing. You have no earthly idea what it means. Okay, it works, but you don't know what you're doing. And we don't want to do that because we got to know what we're doing. So, what really is happening? So, look at the first example. We have 5 negatives and 2 positives. Therefore, our answer has to be what? Negative. It has to be. There's more negatives than positives. Now, this is what happens. The 2 positives, the one with the least, wipes out 2 of the 5 negatives. I'm going to do it without numbers. Let me do it with signs. Here's -5, -1, 2 negatives, 3 negatives, 4 negatives, 5 negatives, right? There's -5, you agree? Here's +2, 2 positives, right? So again, here's what happens. 2 of the positives wipe out 2 of the negatives because they're opposite numbers. They're 0. Gone, right? This is gone, right? And what's left? 3 negatives, and so the answer is -3, right? Because that's what's left. That's what's left. 3 positives wipe out 3 negatives, and what's left is the answer. So on the second one, is the answer going to be positive or negative, class? Positive, because there's more positives than negatives. And 9 negatives are going to wipe out 9 of the positives. So how many positives are going to be left? 5 positives are left. So if I were to write it, I would do 9 negatives and 9 positives, right? And the 9 positives came from the 14 positives. And there are 5 positives left. And these wipe each other out. And so the answer is 5, right? If I were to do it that way. And we spent a couple days with that in pre-algebra. And then the next day we went right to this, right? So let's figure out how to do it fast. And let's figure out how to do that then in our head, right? And so start with the one with the least, count to the one with the most. Why do you start with the one with the least? Because it wipes out that amount of the one with the most. And we're going to count how many's left. That's what this does. It allows us to count how many are left. All right. So you don't need to memorize all that stuff. So I'll do it a few here like this, and then we'll get fast in that as well. So start at which one has the least? The negatives or the positives? So I'm going to start at 15, right? Start at the number of the one with the most. Not negative or positive, just how many there are. There's 15 negatives, that's the one with the least. Count to what? The one with the most, which is 27. 15 to 27 is 12. Use your fingers if you want. If you need your toes, don't take your shoes off. All right, from 15 to 27 is 12. Which sign does the answer get? A plus sign, because that's the one with the most, and the answer is 12, right? Piece of cake. So number 2. Is this your brain for number 2? 12 subtract 35? Don't do that. Don't do that. Don't do 12 subtract 25. do 12 positives and 35 negatives, right? Right? I'm telling you, all this is 12 positives and 35 negatives. That's the exact same thing, but we don't bother to write all that stuff out. So what do? Start at the one with the least. Start at 12. Count to the one with the most. Count up to 35. So if you start at 12 and you count to 35, what do you get? Right? 12. 22, 32, 33, 34, 35. 23. Use my fingers. Oh, shame. Right? And of course, we talked about it last year. Everybody uses their fingers. All right? Everybody does. So shame on that elementary teacher that told you not to use your fingers. God gave us 10. It works real great. We're not base 5 or base 2 or base 8 or base 10. Everybody uses their fingers. People sneak it because their teacher told them not to use them. What's the big deal? Use your fingers if you need to. Get the right answer. Use a calculator, don't you? Use the calculator. Use your fingers if you need to. All right. Give the sign of the one with the most. So we're going to give a negative sign, right? So this is negative 23. And I hope you agree. Negative 23. That's all we're doing. That's all we're doing. And so we did a day of that, right? But we already know how to do this, so that's it for that. Now let's get right down to doing the numbers. So look, that's what we're going to do in our heads. So stay with me, all right? Everybody look up at the board. Don't write anything for a moment. So again, look, this is where your brain should be when you look at number 3, right here, right? This is where your brain should be. All right? Because these 12 wiped out 12 of these, I'm going to figure out how many are left. 12 of them are gone. So by counting from 12 to 45, I'll figure out how many are left, right? So from 12 to 45. 22, 32, 42, 43, 44, 45. That's 33 of the negatives are left. The answer is negative 33. That's what's going on. That's what's happened. That's why the answer is negative 33. Those 12 positives wiped out 12 of those negatives. How many are left? 33 negatives. You got to figure out how many are left. Whenever it's positives and negatives, you got to figure out how many are left. That's what you're doing in your brain. Okay? So it should be quick. Get to 4, count from 11 to 56, and you just figured out that there are 45 positives left, right? And hence the answer is 45. Again, this is exactly what's going on, and it should make adding positive and negatives very easy. You're just counting up how many are left. Just don't get confused between adding 2 negative numbers and adding 1 positive, 1 negative number. And we won't review that. Yeah, we won't review that today. Okay, so go ahead and do 5 and 6. Go ahead and do 5 and 6. Might need to use your fingers. That's okay. Not a problem. You even have a calculator in Algebra 1, so if you really needed to, you could use your calculator. But honestly, for time's sake, you should be able to do stuff like this in your head. For time's sake. Genesis is done. Good to go, Genesis? Is number 5 positive or negative? Are you positive? Is number 6 positive or negative? Are you positive? She's right on those accounts. Then can she count? All right. Sometimes that's the hard part. 78, 88, 98, 108, 118, 128, and then 4 more. Is that 54? So this one's a negative 54. Do you come? Yes, agree? And the second one, 18, 28, 38, 48, 58, 68, 78. That's 60 and 1 more. 61, says Chester. Yes, oui. Certainement. Good to go. How many got that? How many got both? Ah, you're brainiacs. Amazing. All right, math's easy. So again, positives and negatives, you got to be near 100% with these, because almost every problem we do, the rest of your math career has positive and negative numbers. You can't be missing these. You got to understand what's going on. And look, that's exactly what's going on. These 78 positives wiped out 78 of these 132. So we got to figure out how many are left. How do you figure out how many's left? Count from 78 to 132. That's how many's left. 18 of these negatives wiped out 18 of the 79 positives. So we got to figure out how many are left. So start counting from 18 to 79. We'll figure out how many positives are left. It's exactly what's going on. That's the case. And that's how you should do them. Okay, fractions. Well, we spent a whole chapter in pre-algebra dealing with fractions. Spent like 3 weeks on them. And now you got to still remember them. So, somebody raise your hand and tell me how to finish the rule for adding fractions. Edward?
You add the A and B on the top and put 1x.
All right, correct. We add the numerators and put them over the common denominator. The plus minus means I'm showing you adding and subtracting at the same time. Because what does it matter? Because the minus is just adding negatives, right? So the plus minus, I'm showing you both rules at once. I don't know what the fractional phobia is. You know, if you're going to add fractions, you got to have a common denominator. You add the numerators, put them with the common denominator. Why can't we remember that? That's like not even all that much stuff. Got to have a common denominator. Add the numerators, put them with their common denominator. Done. All right, what's the big deal? Daniel, any big deal? Add the numerators, put them over the common denominator. All right. So, let me get rid of my shade, I hope. Come on, shade. Let me put it higher, I hope. All right. So, try not to look at the other questions there. Let's look at A first off. Those of you that are new, let me tell you this. I'm after my students to show the rule step. And guys, in Algebra 1, let's show the rule step one more year. You get to Algebra 2, we'll speed everything up, and we'll do it all in our head. But remember, I am trying to train your brain. So one more time, just include the rule step. So what would be the rule step? The -7 plus the 3 in the numerator, right? Over that common denominator of 10. Does that make sense? That's called a rule step because you're showing adding the numerators over the common denominator. So now you see why this is included in adding positive and negatives, because what's the top? 7 negatives and 3 positives. What does that leave you? 4 negatives, right? So we have a -4 over a 10, and we got to reduce, right? You always reduce fractions. So we end up with -2/5, right? Always reduce your fractions, always reduce, always reduce. Okay, so go to B. Go ahead and do B, show the rule step. I'm going to do it on the screen while you guys do it at your seat. If you're not sure what to do, look up. If not, do it yourself. Reduce if possible. Reduce if possible. Show that rule step. By the way, usually we'll leave things as improper fractions. We won't go to a mixed number unless it had a mixed number already. Those of you that forgot how to reduce, you factor top and bottom, divide out common factors, right? Should have gotten a -11/8. You concur? Because 5 negatives and 17 more negatives, right? Be careful. You're adding 2 negatives there. That's not 1 negative and 1 positive. That's 2 negatives. 5 negatives and 17 more negatives is 22 negatives. Don't get confused between adding a positive and a negative and adding 2 negatives. So I just need you to tell me, raise your hand if you did indeed get -22 that first time. Let me see your hand. You got -22. Okay. Just want to make sure, because you got to be careful there, right? It's different when you add 2 negatives than when you add a positive and a negative, all right? So 5 negatives, 17 more negatives, 22 negatives, and then reduce. Okay, so you look at C, and what should be your first thought? Somebody raise your hand and tell me your first thought. Allison? Got to get a common denominator, right? You look at it, you say, don't have a common denominator. And so remember, guys that are new, it's always the denominator you're looking at now. So what would be our lowest common denominator, class? 6. Can you get a 3 to be a 6? See, I'm looking at the bottom right here. And I'm thinking, I need to multiply that 3 by a 2 on the bottom to get it to be a 6, right? And then, class, you remember what? Whatever you do to the bottom, do the same thing to the top, right? You got to multiply the top by a 2 as well. So here's how I would show the next step. I'd show the rule step next. So the left is a 5 and plus sign, and the right is what? A -4, right? Does that make sense? And your bottom is 6 over the common denominator. So 5 plus -4 over the common denominator is 6. And so that leaves us what? 1/6. Right? 5 positives and 4 negatives leaves you 1 positive, right? 4 negatives wiped out 4 of the positives. There's 1 positive left. Oh no, mixed numbers on that last one. Oh my. Okay, remember, don't make the mistake with a negative mixed number. So for the sake of you new people, let me just remind you how to convert a negative mixed number into the correct improper fraction. Take your negative sign and use a parentheses. Now, by the way, class, you don't need to show me this step anymore. I assume you're going to do this in your brain, and that's okay. But for the sake of the new people, then it's the 3 times 2 plus 1 all over the 2. You got to be careful. They're all negative. So if you try to do the shortcut, class, if you look up here, if you try to do this shortcut, here's where students get in trouble. So guys, look at the screen for me for a minute. Everybody look at the screen for me for a minute. Elise, look at the screen for me for a minute. Okay? This is what students tend to do. -3 times 2 is a -6. -6 plus 1 is a -5. That's wrong. It's -3 times 2 is a -6, and one more negative is a -7. Don't make that mistake. And that's why I taught the pre-algebra class to do a parentheses with the negative out front so you don't make that mistake. So again, if you're going to do it in your head, this is how I do it in my head. -6 and -1 is -7. But if you can't do it in your head, then do the step. Okay, so let's finish this thing off. Okay, so now we've got -7 over 2 plus 1/5. And now we got to do something to both to get a common denominator, right? We're going to go to 10. So multiply a 2 by 5 on the bottom. Whatever you do to the bottom, do the same thing on the top. Multiply the 5 by 2 on the bottom. Whatever you do to the bottom, do the same thing on the top. Just show the rule step, those of you that are done already. -35 plus 2 over 10. 35 negatives and 2 positives leaves me 33 negatives. My rule, if everything's mixed numbers to begin with, leave your answer in mixed numbers. Here we got one mixed number, one fraction, so I'll take it either way. I would just leave it as an improper fraction. It's one less step, less probability of messing it up from here. I would leave it as -33 over 10. If both were mixed numbers, I'd convert it. So look, we went all the way from properties, adding negatives, adding positive and negatives, and doing fractions. Wow. But we learned all this stuff already, right? Those of you that are new, just be careful that you can do these things. All right. You got 10 minutes of class time, which is great. Some of these will go very, very quickly, but I also have a worksheet for you, unfortunately. And I think we'll do the worksheet together right now and belt it out so that you'll only have the other problems at the bottom to deal with. Those of you that are new, again, be careful, because I know my pre-algebra students know this stuff really well on this worksheet. So we're going to do this worksheet together right now. So you won't have to turn in the worksheet tomorrow. We're going to do it right now and get it done. This way I'll cut down on your load tonight. So let's knock out this worksheet. So grab something to write with. Stay with us because I'm going to do it right now. If you miss it, you're going to miss it. Here's number one. The blank property always gets you back to the original. Class? Identity. Number one is identity. Question. You guys need one? All three of you? No, it can't be all three of you. I only have two left. Anybody have an extra? No one. All right, Scott, I'm all sitting on his desk. There we go. All right. Yeah, no one. I always start them the first guy in the row, and then they pass them back. You'll get used to it. All right, so number two is, what are two numbers where their sum is 0? Opposite numbers. Opposite numbers. Number three, the associative property states that changing the blank will not change the value. Associative, changing the grouping. 3 is grouping. Number 4, the additive inverse property involves adding opposites. 4 is opposites. Number 5, the blank property states you can change the order. Commutative. C-O-M-M. U-T. A-T. I-V-E. All right, what property is number 6? Say the property. Associative, right? Because we changed the grouping. So that would be C. Number 6, we changed the grouping. What property is 7? What property is 7?